All right. So now, if you don't know assembler, you might want to practice with assembler, and this is one way to get started. These three pretty much go together. There's this thing called Jasmin that you can download, and Jasmin is a Java-based simulator. It'll run on any platform, and it simulates a 32-bit Intel processor. You can see the registers here like EAX and EBX and ESP, the top and bottom of the stack, ESP and EBP, and the instruction pointer. And you can see the code you type in here, and here's memory, including both the stack and other parts of memory. And there's help here, so you can just type in commands here and run and stop them. So if I just put in move EAX4, move EBX6, it'll put a 4 in EBX and a 4 in AEX and a 6 in EBX. And so you can do this. This will move, and I can move data to memory. So if I move a 4 into EAX and a 6 into EBX, and then I move EBX into bracket EAX, that will take the EAX value as an address, so it puts it at this memory location 4. And the memory locations count by bytes, but on a 32-bit processor, the word is 32 bits long, so it goes up by 4s here. So when I write a 6 into location 4, I write a 32-bit word ending in 6 into the 4 bytes starting at location 4. And so on. And then you can use the stack. You can push things on the stack, push EAX, push EBX. And when you do that, they will appear at the bottom of memory where the stack is. So you will see before you run it, there's nothing in the stack. And when you run it, it will push those onto the stack. The 4 goes here, the 6 goes here, push puts them on the stack, and pops them off the stack. So anyway, you can practice writing basic assembly code here, and it gives you nice help messages to train you. So this is a really good tool to use to start understanding how to write assembler. IDA Pro is the main tool you use to get the assembly language out of files, although Ghidra, in my opinion, is beginning to replace it in a big way because IDA Pro is very expensive, and Ghidra gives you a lot more functionality for free. But the free versions of IDA Pro are still commonly used, and the real professionals pay the thousands of bucks and get the full version of IDA. It is the pro tool like Photoshop. But anyway, you can use the free version, and you can examine files, and it'll show you the assembly code and connect it with arrows as to show you this block of code is connected to another block of code. And if you have an if statement, this is like compare something and jump if it's 0. So if that condition is true, you follow the green arrow, and if it's false, you follow the red arrow. So it gives you this overview of files, and you can use it to see the raw assembly code bytes. And it's pretty complicated to use. There's a learning curve to get used to it, but you can learn to flip between the views, and you can now look for Windows calls, like get host by name is a Windows routine that does DNS lookup. So you can go and view functions and find that particular function. And when you double click it and then press, I think, Control X, it will show you all the locations that call that function. And you can double click those, and it will take you to the code that does it. So in this particular sample, you can find that it calls get host by name here, doing a DNS resolution. And then if you just scroll around, you can deduce what it's doing. You can go to the name here, the location of the name that's going to be used, and you can see the name of it. So you can find the command and control server URL right here. And we've done this before with just strings by finding something that looked like a URL and guessing, but now you have actually proven that this is actually used to make a network connection. And so you can find the domain name, and then you can find what this malware does. If you look at the strings in IDA, you'll find //cmd.exe/c. And cmd/c is how you run a console command from a script. So if you double click that, you'll go to where that string is stored. And if you go to the cross-reference of it, you'll go to the code that uses it. And that code is pretty easy to read. If you just look at the stuff on the right, it's pretty easy to read. This here read the highlighted stuff is there for your reason. You get startup info. This is some Windows API that gives you general information about the system. This gets you the system directory, and what it's looking is to see if your machine is using C Windows System or C Windows System 32. They're seeing if you have a 16-bit version of Microsoft, really old, or if you have a 32-bit version. And then it's going to run cmd.exe if you have a 32-bit Microsoft. But if you have 16 bits, it's going to be command.exe, which was the command processor in MS-DOS. And so that's the decision made here. And if you scroll back up and look at the earlier code, you'll find readable strings. Hi master, this is the botnet command and control panel. And it's going to send a signal to the master with information about the system and then take a variety of commands and execute them. Welcome back. Are you enjoying today? Machine uptime. You can execute commands, and one of the options is to give it a command line to execute on the machines, and then it will execute the command line after deciding whether you have 16 or 32 bits. And there's some crack bees here where you have password guessing games, and you can read the assembly code to figure out what the right password is. So these are standard things you do to learn assembly. And another thing which is important is to learn how to spot common structures in assembly. So here's a program that just prints hello, and you can see how calls are made. So this prints a number 2 and then a string hello. So if you decompress it with IDA, decompile it with IDA Pro, and then find the actual code, you will see here's the code that does it. And this is what you do to call a function in assembler. All the parameters are on the stack. So first you have to push things onto the stack. First you push a pointer to hello, then you push the number 2, then you push a pointer to the format string, %d, %s, and then you call the function. This system has strange consequences. When you call a function in the C library, it looks on the stack to find the parameters, and it has no way to know if you actually correctly put those parameters on the stack. So this leads to format string vulnerabilities, where you can call a print statement and you can put unexpected things, and if the programmer forgot to put things on the stack, you will just reveal values on the stack that the programmer didn't expect you to see. Anyway, you can see how global and local variables look in assembler and so on. And these are the basics of how you learn how to read assembler and have a pretty good clue what's going on. Although if you use GIDRA, it will actually decompile code back into C. So you don't have to read the assembler directly so much, and that is wonderfully handy, but you never really get away from needing to know assembler in this business. You can do a lot without it, but you're constantly running into limitations where you really wish you knew assembler. So if you want to practice with assembler, I wrote an assembler CTF here, and you can do a bunch of these where you just practice writing assembly code. So you can install an assembler, compile simple programs, and then solve simple problems here with assembly code. So you might want to check that out. All right, and actually, you don't need to go to that link. I've included it here, at the bottom. Those challenges are just right here. I'll take that other link off because that goes to a different scoring engine and that's confusing. Here you can just practice writing assembler here. And that's a good skill to know. All right, let me save this one.